Hello, everybody. I'm very happy to be here. My name is Srinivasan. I'm a research scientist at IBM Research, New York. And I'm going to be describing release engineering for Knative applications using Iterate. So we presented Iterate early this year, kind of when it was still in formation, I would say. Iterate has evolved significantly since the last presentation. So I was thinking maybe I could start with the level set of what Iterate is. And also focus on the new capabilities, the GitOps friendly capabilities and Helm friendly capabilities of Iterate. Which is what I'm going to present today in the talk today. Sounds good. Okay, so first of all, what is Iterate? Iterate is the release engineering platform for Kubernetes. And it's really a tool intended to automate SLO validation, or A/B testing, ABN testing with multiple versions, progressive rollouts with advanced traffic engineering, right? So it's meant for DevOps and MLOps teams that are interested in release engineering with these types of features. Iterate is really extensible, so you can really use it in any Kubernetes environment. Of course, the focus of today's talk is going to be on Knative. And you can use Iterate with any CI/CD GitOps tool. Also, the focus of today's talk is going to be on Helm and also partly on GitOps tools. So the basic idea is that with Iterate, you can assess different versions of your applications, find a winning version, and safely roll out the winning version. So most often, you have a new release, you just want to check SLOs. If it passes, it's the winning version. Otherwise, your existing stable version is the winning version. But in other types of experiments, for example, you're doing A/B testing or ABN testing, you may want to use actually business metrics. Whichever version is maximizing your revenue, that's the winning version. So you can really assess your versions in lots of different ways using Iterate and do the promotion. All right, so briefly, features at a glance. So as I mentioned, you can use different assessment strategies as part of the Iterate experiments. And you can also use different rollout strategies. Sky's the limit here. So you can dark launch, perform an experiment, and then decide to roll forward. You can do progressive traffic shifting. You can do a fixed percentage split, or depending on the kind of networking layer that you have, and depending on the level of support that you get from the networking layer, you can pretty much use all features, traffic engineering features from your Kubernetes cluster as part of your rollout strategy. And in terms of metrics, so Iterate comes with a built-in metrics collection capability. So you can use it to collect latency and error-related metrics using test load for your applications. You can also use metrics from any database, definitely from Prometheus or pretty much anything that is RESTful that you can query. You can use it as part of Iterate. There are also very advanced algorithms behind the scenes to optimize progressive rollouts and traffic shifting. And this is also sort of showcased in many of Iterate demos already. Okay, so with that background, let's also quickly jump into the core concept of what Iterate is and what an Iterate experiment is. So essentially, Iterate introduces a new Kubernetes custom resource called an experiment that automates these experiments. SLO validation, A/B testing, ABN testing, and progressive rollout experiments are automated by this experiment resource. And essentially, at the beginning of the experiment, you can perform certain tasks. For example, check the readiness of the resources that you're experimenting with. During the experiment, you can observe metrics, you can assess versions, split traffic, change the traffic percentages. You can do all this automatically. And optionally, at the end of the experiment, you can promote a winning version, and there are different ways to do this version promotion with Iterate. Iterate also makes it easy to embed experiments as part of Helm releases. This is exactly the point of today's talk. So we call this pattern HelmX. It's simply a Helm release with an Iterate experiment in it. When you do HelmX experiments, your Helm values file are required to satisfy a certain schema. It makes it much easier. It's not strictly required, but if your Helm values file satisfies a simple schema, it does make the experimentation process easier. So we will take a look at the schema also in today's demo. Okay, so let's get started with our first Knative experiment, right? What is the problem we're trying to solve? What are we trying to achieve in this experiment? So you already have a baseline version of the application. It's running in your cluster, and you want to dark launch a new version, V2, and you want to do some testing on it. Just make sure it has good latency and error rate values. And once you're satisfied, you want to promote this new version as the new baseline. So it's a simple SLO validation. Make sure your new version is working the way you would expect it to work, and then do the promotion. Of course, you're probably going to do this in your test cluster also, but conditions in your test cluster may not always be the same as conditions in your production cluster. So it's independent of what you do in your test cluster. You may still want to do some level of validation before you expose your new version to end users. And that's what this release experiment is going to demonstrate. So I already went through the setups. By the way, everything I'm talking about here is public. It's all documented on iterate.tools. As you can see, I'm driving this entire discussion using the public website. So please check it out, try it out yourself at your convenience. Everything is 100% open, Apache V2 license. You can use it readily. So, okay, so I already did the setup steps here. So I have Helm locally, and I have a local Kubernetes cluster with Minikube running. I have installed Knative in it. And this tutorial doesn't depend on any particular networking layer. You can really use it with any Knative networking layer. So it works with all Knative networking options. In this particular case, I'm using Courier because it's fairly simple to install, but it works with anything. I already went ahead and installed Iterate in the Kubernetes cluster. And Iterate comes with a command line tool called iterate-ctl that will help me understand the experiments, debug the experiments a little bit. So we'll take a look at that also. And I believe I added the Helm repo that hosts many of the sample charts and the experiment charts that this tutorial requires. Okay, so I added the Helm repo also. So with that setup, we are ready to get started. So let's create a baseline version of our application. So I'm going to use Helm to create a Knative application. It's version 1. It's just a simple hello world application. Okay, so let's look at what we just deployed. It's a simple Knative service. I have a hello world image here, and just for fun, I added an annotation that says, don't scale down to zeros. If you want, you can scale down to 1, but it can be any template, service template of your choice. This is a simple example. Okay, so let's go ahead and pretend that we have a new candidate version. So we have version V2, and we want to side-by-side deploy V2 also along with V1. So as I discussed in this picture, you have a stable version, and alongside you have a dark launched V2 that we want to deploy, and that's what we're going to do right now. So let's go ahead and deploy V2. Okay, V2 deployed, and let's take a look again at what we just deployed. So there are a few different things going on here. So first of all, if you look at the service, the revision template within the service has been updated, right? So now you have 2.0 instead of 1.0. So you have V2 as the new revision. And your baseline version is still getting 100% of the traffic. So all user traffic is really going to the baseline. And the candidate version is not really at the moment visible to end users. So it's getting 0% of the traffic. what that lets me do is do some experiments with the candidate version, make sure it's working okay before I really promote it to 100%. So, and I'm going to do that using this iterate experiment. So as I said, experiment is a custom resource defined by iterate. And let's kind of focus on the actions part of the experiment. So this is what the start action is what iterate is going to do at the beginning of the experiment, right? At the beginning of the experiment, first of all, it's going to check the readiness of your Knative service. It's not going to start the experiment until it is ready. So once it is ready, so I noticed that, even though Knative declares the service as being ready, the route is actually not available. So there are some DNS issues, and the route wasn't actually available for querying. So maybe it is something to do with my cluster setup, or maybe it is something to do with glitchiness in Knative. I don't know. It doesn't matter, because I can just let things settle by creating this additional task, which just asks iterate to sleep for 30 seconds, and then continue with collecting metrics for the new version. Incidentally, Zoom is telling me that audience can now see my screen. Does that mean you were not able to see my screen until now, or was it okay?
Oh, no, we've been able to see your screen all along. Don't worry. That's
Yes.
Okay, that's nice. So it was just Zoom catching up. Nice. Okay, so okay, my service is ready. I slept for 30 seconds, and now I'm actually going to collect metrics for the candidate version. And for this, I'm going to use the built-in metrics collection capability of iterate, and it's able to collect these metrics from it. It's able to collect latency and error rate related metrics, including tail latency metrics. So that brings me to the criteria section. So I can actually say that during the experiment, verify that the mean latency is within 500 milliseconds, the error rate is within 1%, and my tail latency is within 1 second. Of course, you can change these values as it makes sense for your application, but this is an example. These are the criteria that I'm going to use to verify that the application is working as promised, as expected. Okay, so this experiment has already been deployed by Helm. And let's now see, the experiment has probably completed. So let's actually describe the experiment using the iterate command line tool. And yes, so as you can tell, iterate CTL is telling me that the objectives are being satisfied. The SLOs are being satisfied by the new version. Its mean latency is indeed within the limit that you set, and so are the other objectives. And if you want to know the actual metric values, you can see that also here. So there is no errors. Mean latency is 7 milliseconds and 12 milliseconds for tail latency. So everything is looking good. So we are just ready to, well, let's also assert that indeed everything is looking good. Experiment has completed. Winner has been found. Great. So we are ready to move it forward. We are ready to promote it as the new version. So notice that I'm now setting the baseline tag as 2.0 and the baseline ID as V2. So that is the upgrade to the application that I am going to do through Helm. Okay, so everything is good. Let's just get manifest, make sure. Right. So when I do a get manifest now, notice that the experiment is actually not there anymore because you said candidate equals null. So there is no need for the experiment anymore because it's now the new stable version. And as you can see, it is indeed the new stable version. There is no traffic section, which means it's getting 100% of the traffic. So that's a very imperative command line way of doing it. This is just an initial demonstration of what an iterate experiment is. So a few things. Okay, let's actually clean it up. Let's take out the application. You can use this chart actually in production. So you can use the same experiment if you have Helm charts for Knative services. You can embed the same experiment or modify the experiment, which definitely will want to modify your application templates in Helm. So, but you can essentially use this chart by modifying the chart that I just showed you for your usage scenario. And there are a few other things. So we are going to look at this more GitOps friendly way of doing the same experiment instead of doing a command line Helm upgrades. And there are also a whole bunch of other tutorials for Knative we've documented here that do not really require Helm. These are more raw experiments, right? So we don't actually discuss the templating part of the solution in these tutorials. You can try them out also. So I'm going to move on to the more GitOps friendly version of this tutorial. But let's pause here and see if there are any questions. I'm just going to open the chat. Imperative way is very useful to get started, understand the tool. Yes, that's exactly why we are documenting it. Okay, so any questions? No, let's move forward. All right, so this is kind of the same experiment that I just showed you. Once again, we are going to dark launch a version of your application, and we are going to promote it. But here's the twist, right? So Helm uses, as you know, Helm uses a values file. And the values file is now going to reside in Git, in a GitHub repo. And this values file, this GitHub repo will be the source of truth for your application. So in particular, all changes to your application will go through this Git repo, right? So initially, there will be a baseline version in the values.yaml file. And I am going to manually edit the values.yaml file to create the candidate and experiment. And I'm also going to do a manual sync. So we will come back to these manual steps, right? So the focus is on the interaction with the Git repo in this demo. So obviously there are many steps that I'm going to continue to do manually, but they can all be automated with a GitOps operator like Argo CD. So we'll come back to this Argo CD integration in just a minute after we go through this demo end to end. So again, the candidate and experiment is going to be sort of declared in the values.yaml file in the Git repo. And this is going to trigger an iterate experiment. And the interesting part here is that the iterate experiment at the end of the experiment is going to automatically update the values file in the Git repo. So the version promotion that you saw me doing, CLI mode, that version promotion is going to be done by iterate, and it's going to be done by iterate automatically by pushing changes to Git repo to this values.yaml file. That is the flow of this demo. So it's essentially the same cluster setup as before. So let's continue. So I already have a fork of the repo that I'm going to use, and I cloned it locally. So I'm just going to this temp, and let me start by doing this step, right? Fork and clone. Actually, let me start by doing the fork and clone. So this is just the Git repo that I'm going to use for this experiment, for this demonstration. That's my GitHub username. And let me clone the repo. And let me just create a branch for me to work with. This is a branch that we will use for this GitOps friendly experiment. Okay, so let's first of all take a look at the values file in this repo, right? Let's take a look at what's in it. So I have it's kind of the same, whatever you saw me do with Helm set commands, that's kind of what is there in the values file. I'm just going to use the values file instead of the set command. So there is a common section, which is common to both your baseline and candidate versions. They have the same application name and they both have the same repo, but they change in terms of their tag and their IDs. So my baseline is going to have a 1.0 tag, and candidate, whenever it comes, is going to have a 2.0 tag. Right now, there is no candidate, so it's just the baseline. And let's do a sync of this Git repo with the Kubernetes cluster. Obviously, this Git sync is where tools like Argo CD get into the picture. But for now, for the sake of this demonstration, let me just do a manual sync of the repo with the cluster. Okay, so I can do once again, I can do a manifest. And this is what we just synced into the cluster. So once again, I have a baseline version, hello v1. And it's, yes, so with image tag 1.0, and that's what we just deployed. Now, as I mentioned, what I would like to do is run an experiment with a candidate and automatically change the values file in the Git repo. Obviously, if you want an external component to touch your Git repo, then you will have to give it some permissions to actually modify the Git repo. So that's what I'm going to do here. So I already went ahead, created a GitHub access token, personal access token. So I am going to create a Kubernetes secret with that token in it. So let me do that as follows. So now I can create a Kubernetes secret with my GitHub token. Done. And I can also permit iterate to read this token, because it's going to read this token and use it to make changes to the GitHub repo. So let me just give it permissions to read this particular secret that I just created above. Done. Iterate can now read the GitHub token that I just created. All right, so now let's go ahead and update the values.yaml file so that it has a candidate. In addition to the baseline, it also has a candidate version. That's exactly what this is saying. So I have a baseline version. And incidentally, this is the simple schema that I mentioned in the beginning of the talk. This is the actual Helm schema. There is a common section. There's a baseline section for your baseline version of the application. Then there is a candidate section for the candidate version of your application. That's all there is to the schema. And obviously, as you can tell, it makes it a little bit easy to structure new releases and experiment with them. Okay, so let's go ahead, update this values.yaml file locally first, and then we will push it to the Git repo. Of course, once again, this is all expected to be performed by your CD system, right? So our CI/CD system. So you will have some process to create, to build, maybe a Tekton pipeline to build this new image and publish it to your image repository. And once the image becomes available, there is some pipeline that is actually pushing this change to the values.yaml file, indicating that there is a new candidate available. So that is the part that I'm really short-circuiting and simulating here by changing it locally and pushing it to Git. So, okay, so change it locally. Let's push it to Git. And let's also do this curl command to verify what we just pushed. So if I do a curl, now I see this in my values.yaml file in my Git repo. So it's definitely pushed the right thing. So I have a baseline version, candidate version. And incidentally, it's also, okay, so let's do a Helm upgrade. This is the creation of the candidate version in the cluster. This is the cluster sync step. And it's also creating the experiment as usual. So whenever I create a candidate version, I'm creating the associated experiment with it. So let's do the Helm upgrade. And now let's take a look at the manifest that we just deployed. It's kind of similar. The Knative service now has Hello V2, but it is dark launched because, as you can tell, the latest revision is getting 0% traffic, and V1 is getting 100% of the traffic. So let's take a look at the experiment. Once again, it's kind of similar, the same kind of start actions. It's going to check the readiness of the Knative service. It's going to sleep a little bit, to ensure there's no glitchiness. It's safe to start the experiment. It's going to collect some latency error rate metrics. Here are the criteria. It's the same criteria we used in the previous experiment. What's interesting about this is the finish action here, right? So once the experiment actually completes, it is going to do update to your Git repo, and it will do one of two things, right? If the new version is successful, it's meeting the SLOs, it's going to promote the new version. If the new version is not successful, it's just going to roll back the new version, simply going to delete the candidate section. That's what it's going to do. We expect this experiment to actually succeed the candidate version to just work and satisfy all the criteria. So hopefully what we will see is the actual version promotion. So, okay, so we did this, and let's now take a look at where the experiment is at. Describe the experiment. Very good. So once again, everything is looking good. Your candidate is satisfying the objectives, and the metrics are all, there are no errors and very low latencies, mean and tail latencies. Everything is looking fantastic. Once again, let's assert that, we found a winner, the experiment found a winner, and our experiment completed, all good. Here is the GitOps promotion by Iterate, right? We are not going to do a manual promotion because Iterate is already promoted the version in Git. So before it did the promotion, this is how your Git values file looked like. And after it did the promotion, this is how your values file looks like. So before you had a candidate 1.0, sorry, baseline 1.0 and candidate 2.0. After, there is no candidate because the candidate became the new baseline, and the new baseline is 2.0 V2. So this is what we should really see in Git. If we check out this file in Git right now, according to Iterate, this is what we should see. So let's do that check. Oh, what happened? Did I mess up some step? I wonder what happened. This was the step where Iterate was expected to promote the candidate version, and for reasons unknown to me, it didn't quite actually do that. Maybe I messed up the GitHub token, maybe it couldn't read it. So we can come back and take a look. But the expected behavior from Iterate is that this is the change that you will see in the GitOps repo. This is what I was seeing all along, and looks like Murphy's Law has caught up with me, and I'm not seeing it right at the moment. So let's just give it one more try. Let me just verify the experiment. Finished. Okay. Experiment seems to have finished okay. So maybe I messed up something in the way I set up my secret or something like that. There was no errors, there was no failures or anything during the experiment. So something to do with my GH token, probably. So anyway, long story short, what you would expect to see after this step is this. You would see a promotion like this, and that's the version that you will git sync into the cluster. And that's really about it for this GitOps friendly way of doing it. So let's take a step back. There were a lot of, yeah.
Can you open the GitHub repo with the browser instead of using the curl? Because it could be a cache problem.
Oh, I see. That's a very good.
Somebody said that they wanted to see some GitOps troubleshooting, so that's how you.
You're right. You're right.
Yeah.
So absolutely right. I just curl again, and it's looking good. It is a curl cache problem because I used the exact same curl command, and now it's giving me the right thing. So it did actually do the promotion. This is what you're saying.
I'm still kind of interested. Like, if something goes wrong in between these, like how are you supposed to like debug? Like, it's always been something I've wondered about, like the GitOps kind of thing. It's like, where do you see that it went wrong, and like what would you have done if that happened for real?
Yeah, that's a very, very good point, right? So there are ways to debug the iterate experiment itself, right? So the experiment, as I mentioned, is a Kubernetes resource. So in the status section of the experiment, if something's going wrong, you will see why it went wrong. Experiment will fail, basically, and you will see the reason for why the experiment failed. Maybe because you weren't able to collect the metrics the way, or get at the metrics the way you were supposed to get at. Maybe you haven't set up the metrics properly, or maybe because the way you configured the experiment with these tasks is wrong. So you will see the appropriate reason. When you see the experiment failing, you will see the appropriate reason within the iterate experiment itself. But you are right.
But the GitHub token is wrong, right? Could be like the GitHub token is wrong. The iterate print a message.
Yeah.
In a way, my question is slightly different. So if your main UX is GitHub, right? Then and you're letting it all happen in the background. I guess I'm wondering, like, if I'm doing everything by PRs, how do I see that my experiment like failed? Or that they're out of sync, right? Because you now got out of sync between the two. And I guess I'm wondering, like, what the mental model is if I use this, like if I do the experiment, how do I kind of see the progress of it and that it failed somewhere? If you see what I mean, right? Like, what's the correct workflow if you're in GitHub?
So absolutely yes. So there is a notification mechanism also that Iterate provides, right? So at various stages of the experiment, you can actually use a notification to notify anything, anywhere, any HTTP endpoint, post endpoint, or GET endpoint. So, and it will contain details of the experiment. So it will contain details about where the experiment is and how far it has progressed. And if you will be able to see the status section of the experiment and see that, this is what has happened so far, this is yet to happen. So you will see that notification. The other point, it's kind of interesting that you brought up PRs here, right? So I purposefully, for the sake of simplification, I'm demonstrating a git commit here. That's what Iterate is doing with the token. But presumably you can use, first of all, you can use a branch where I am pushing to create a PR. That's one thing you can do. And so you don't have to directly modify the values file in the end repo. You can do it through a PR for sure.
Nice. So I guess if this was like a kind of real production setup and that had happened, like we'd have got like a Slack notification, or it would have created a GitHub issue or something. That's the idea.
Right. So there is already Slack notification supported by Iterate. So you can use, just jumping ahead a little bit here. There are different tasks that you can embed within the Iterate experiment, and one of them is Slack notification. The other is the HTTP notification that I talked to you about. And you can, notify your GitHub Actions workflow and trigger it using that, or you can use a Tecton trigger any whichever way you want to use the notification.
Or you can use the cloud event I heard they're good.
Mhm.
You can use a cloud event. You have a lot of flexibility in how you format the notification. So I guess cloud event is just a notification format. Certainly you can use a cloud event format.
Cloud
as part of
event
notification.
to Knative service running in an iterated experiment. That's what I want.
Yes, and the GUI with the progress bar. That's what
Exactly.
Jose is asking for. The iterate progress bar.
Right.
Iterate. I see. I see. Coming soon. All right. So, okay. So, okay. So far, let's continue with this. So we're almost there. So it actually did the right thing. And let's sync up the cluster. And this is what we get synced, right? Synced into the cluster. So we have P2 now promoted and running into the cluster. So yes, a lot of the steps that I showed you right now in this are really manual. However, the key takeaway is that the source of truth about your application in this example is GitHub. And that's what is getting changed. And all the steps that I demonstrated manually, you can certainly automate it using either, you can use Argo CD to do, pull-based GitOps. You can use any GitOps operator, Flux CD or Argo CD to do pull-based GitOps, or you can use, your traditional pipelines to do more push-based GitOps. So you can set up your CI/CD system any which way you want. This was more about how Iterate would plug into your system, and there are lots of different ways it can plug into it. You can use notifications, you can use git commit, and you can follow up the commit with a PR. I think that should also be, we can extend the task to do it, but I'm pretty sure you can set up your Git to create not a PR once a branch has a push into it. So those are some of the options. Okay, so everything I showed you today is about using Helm and using Helm in a GitOpsy way. You can also try out some of these other tutorials that are definitely more advanced, right? There's more progressive traffic shifting of the traffic going to the winning version, and there's also A/B testing, ABN testing, hybrid testing, lots of different assessment strategies and testing strategies, and also user segmentation, right? You want to experiment on let's say, subset of users using HTTP headers and leave out others, don't disturb the others. The others just go to the baseline. They're not participating in the experiment. If you have something like Istio networking layer, you can do some of these more advanced experiments using Istio virtual service capabilities. So that's also documented already as part of the Knative tutorials. That's really what I wanted to present. Let me pause, see if there are any questions.
While people come up with questions, I'm going to launch the poll. Please help us by answering the poll for this session to provide us some feedback. In the meantime, we are open to any questions or comments you may have.
I have a question about progressive traffic shifting. In Knative, we have something called rollout duration, where we do a traffic, we take them a certain amount of time and we do steps until we move to the new desired version, which is the latest. How does, if you can talk a little bit about this example that you have down there, progressive traffic shifting, do you take into account like how long does it take to move or iterate? So the reason that we did that in Knative at the beginning was like shifting to 100% to a new revision, and you have a lot of demand on the system, you will get a lot of errors. So when when people do rollouts in these situations, the amount of time and amount of percentage step that you roll out to the new version is very critical, and that could change your error rate, your SLO budget in that burst. Do you take that into account when you say progressive traffic shifting in this case?
So let's try to understand the question. So I didn't know this. So Knative has a feature for moving the traffic percentages. Is that what you're saying?
Yeah, we have something. It's called rollout duration. It's, I don't know if we call it experiment right now. Somebody can chime in. But yeah, you can set it to 1 hour, for example. It's just a one single config with a amount of time. You can say 1 hour, 10 minutes, and then it will take that 10 minutes and I progressively shift the traffic percentage, basically just change the traffic percentage to the new candidate, to the new latest. How does your progressive traffic that you want to have at the bottom here, does something similar like that, or what is the progressive aspect of
I
that
think
one?
yes. So it's a related concept. That's interesting, actually. I didn't know about this. So there are two differences here, right? The way I can tell. I think the iterate is obviously leveraging the same mechanisms. So when you do a progressive traffic shift, in particular in this tutorial, when you do a progressive traffic shift, it is using the service, the traffic section within the Knative service to do the progressive traffic shifting. So it is underneath the covers. I think it is the same mechanism. I'm not sure how the Knative native traffic shifting is implemented. But
I can jump into this. So the rollout duration thing is it's like very simple, and when we added it, we almost didn't add it because we didn't want to conflict with stuff like this. But we added it just so that you don't have a bad time when you roll out a new revision and you've got loads of load and you go to a new revision. We didn't want like all the traffic to go to the new one before it had scaled up. So it just like basic traffic shifting, like when you do a new revision, so that it doesn't immediately slam all the load onto the new revision, and it does it kind of, you know, automatically inside the stuff. But I wouldn't see it as like, you know, replacing something like this, which gives you like more knobs and all of that stuff.
So you see, one way to think about it is the experiment that I just showed you. There are lots of different ways to think about it, right? The experiment that I showed you doesn't actually do the progressive traffic shifting. It does a dark launch. Even before any traffic goes to the new revision, it is doing some testing and validation, and then declaring it as the winning version. So perhaps one way to think about it is you can do a validation like this, and then once you're satisfied, you can combine it with the Knative progressive model of, you know, the traffic shifting to gradually ramp up the number of instances of the new revision. That's one way to think about
once
it.
You have the winner. Okay.
Once you have the winner. The other thing to keep in mind is that the traffic shifting here, progressive traffic shifting here, is based on metrics and assessment from metrics, right? So let's say you're collecting metrics using live traffic for both the revisions in your Prometheus. Iterate can be used to query that Prometheus instance and determine who is the actual winner. Is it the stable version you should retain, or should you move to the new version? So it's not just about traffic shifting, it's really traffic shifting based on metrics-driven criteria. What I showed you was how to collect metrics internally by Iterate itself, but the sky's the limit. You can use any metric backend to query as part of the Iterate experiment.
Using Prometheus, right? Format standard, any Prometheus endpoint.
Yeah, you can use any Prometheus endpoint. You know, Iterate actually has a very, very proper custom metric story, right? So you can define. There is another CRD that comes with it. There are two CRDs that Iterate defines. One is the experiment CRD. The other is the metric CRD. Within the metric CRD, you can say that you can define a metric, and you can, part of the definition is what is the backend from which you're going to get the metric, and how do you actually, what are the templates that you're going to use to query those backends. So you can, there's documented examples for how you create, these metric objects for Prometheus with and without authentication or other backend services. We have kind of experimented with these other different backends because there are a few other users and use cases where we have actually had the need to explore these other backends. But these are just the documented examples, but really anything that can be queried RESTfully, you can use it as a source of metrics in Iterate, as per Iterate experiments.
Very good. Thank you.
All right, so I actually wanted to get a couple of things out of this conversation also. One is, the tool is maturing quite a bit. So since we first came to the Knative community and presented it, obviously, hopefully, if you remember that talk, you can hopefully see how the tool is maturing. One thing we would love to do is document something on the Knative side. So we would love to push some sort of a documentation PR that, forget about all the latest and greatest examples, but some simple example of how Knative users can start benefiting from Iterate. It doesn't even have to involve Helm. It doesn't have to involve anything complex. It can be a simple, your first experiment or release automation experiment with Knative and Iterate. So we would definitely want to and love to push something like that. So any guidance on that is appreciated. And number two is we would love to also hear what other types of samples that you would want us to develop in the context of Knative, right? So it is a very, very flexible tool. So if you have ideas on what specific patterns would be beneficial, I would like to hear about that also.
So the first, I can chime in. The first one, be good to open an issue in the docs repo, and then we can have a conversation there. But I think it should be okay, because some people ask about how to do rollouts, and we show how to change the knobs of the traffic split. But this could be one example that we can add. It could be a page under admin, but we can discuss it, or it can be both. It could be a page, but also it could be a blog post. We also do blog posts. I don't know, did Iterate have done a blog post already?
Yeah, number of blog posts, and also
in the Knative, I mean, in the Knative website.
No.
Okay, so maybe that's also the first step, and then the page. So, because the blog post will be more like social type of thing of this is a project that interacts with Knative, who you are, like kind of give the background, and then also so both issues can be open. Go ahead, free open to do that. The other one is the only thing I can think is the one that Jules and we came up with was notifications. So if you can have something around cloud events of notifying as the experiment is going, right? So you have a lot of data points for the experiment, how to capture that into cloud events. And then once it's in a broker, then, the sky's the limit. You want to take that data and put it into a database and show a UI. You want to, have listeners to acting on that data. So things that are happening, Iterate, that are events, facts of life. If you can make them cloud events and send it to the broker, then we can have a story of like extending Iterate based on those cloud events. So one example could be the progress of the experiment. So it takes an hour, and Jules have to have launch, right? All that data points are stored in the broker, and then they're acted on. So that's the only one I can think about. I don't know if other people have ideas. I think Joe's put a message.
I think I said the same thing you said. Post an issue in the docs repo because it sounds interesting to me.
Yeah, I think a blog, starting with a blog, which is more socializing the thing, and then also the page, because the page is like, it's a reference, and then nobody will look, like, nobody know it exists there. Nobody will look for searching for it. But the blog post is the social aspect, the value add, and then also the link to the page.
I do think it could be interesting to have like, I mean, you know, this is up to docs, but like have like kind of integrations with a tools section somewhere, you know, like how to use as with, and then like, you know.
Yeah, actually it's doing a proposal for Knative Sandbox. I know that this project is not in the Knative Sandbox, but that same documentation or policies could be applied to that, right? Same thing for trigger mesh or other integrations.
I think that's a good way of putting it. Like, I don't think we should have a requirement you're in Knative Sandbox for us to, I mean, you can be in Knative Sandbox.
It could be another org.
Yeah, that's cool.
Start collecting those.
Yeah, the only other thing that came to mind in terms of like demo stuff, I mean, obviously like the A/B testing stuff, and the current metrics are like, you know, latency and so on. Be kind of interesting if there was a way, you know, to do it with like feedback and you know, someone was showing us this Optimizely stuff the other day, which works for static websites, but you can kind of like see how long people stayed on the page, right, with like the Google Analytics cookies and so on, between like version 1 with like this header and version 2 with the other header. And I'm sure you could do that with the pieces that you have here, that kind of stuff. But it'd be pretty nice to be able to do that with like my web app that isn't, you know, static HTML and so on.
So I have another. Oh, go ahead. I was going to say, no, we have another metric. One metric that don't have here, maybe you didn't mention, but I think would be maybe useful, is sometimes we develop serverless functions or Knative services, and a developer would make a change in their code or maybe in the Docker file that will make cold start break the SLO. So I may have an SLO that says no Knative service should take more than, I don't know, a minute to be available. So that metric is available, and if a developer did a mistake and now cold starts is being 3 minutes, I don't want to put that in production. So how do I use Iterate to capture that and do that experiment and not put it in production? Does that make sense?
That's an interesting question, right? Your cold start will, if it affects your tail latency, will shoot up if you have a cold start, right? That's what is going to happen, because as you query, if you use Iterate's built-in capabilities to query the dark launched version, and there is a cold start issue, 3 minutes startup, it's going to show up as a tail latency problem. So when you set the tail latency thresholds according to whatever is acceptable for your application, and you find that it's not meeting it, this is one way I can think of where
but that cold start could be one of those 5%. I'm saying that I don't care. You know, you follow? Like the 95%, if we do the 95 percentile, you're saying that 5% of the whole thing, you don't care about those outliers. But if I want to like care about them, how do I go about that? Maybe change the percentages, or maybe changing the percentages.
So you could say, oh yeah, I see what you mean. There are a few different ways to cut this, right? You can assume, let's say you're collecting metrics from Prometheus, right? You can define the percentile as you want, right? You don't have to say 95%. You can define your percentile as you want, and histogram percentile as you want, and say that is the metric that you want, 90th percentile or 85th percentile or 99th percentile, whatever makes sense in terms of tail latency.
But indirectly. Okay, that's a good idea.
Yeah. The other question I think I heard was that, I mean, that's one approach I can think of for capturing the negative effects of cold start, right? You want to actually make sure that the cold start is not too bad, because if it is, then you don't want to promote it. This is the way to do it. You may also argue that, you want to ignore it. So if there is a cold start, then forget about it. It's going to go away once it starts receiving traffic. So maybe it's not an issue for you. I think it can cut both ways. You can perhaps just send some load test traffic, make sure you get past that cold start hump, and then you can do the rest of the experiment. That's definitely possible. The other question I heard was about the A/B testing and optimized use case, right? So there is actually an A/B and SLO combined testing experiment that's documented in iterate.tools. by all means, try it out. It's not, it's still not worked out. It's not as clean as the one that I showed you, but it's a more of a raw experiment, doesn't involve Helm. It is possible today to do A/B testing with Iterate and Knative. And perhaps it would be interesting if we come back with a way to demonstrate it using, let's say, Google Analytics or something like that. This is using a fake user engagement metric, but I guess what you're asking for is a real user engagement, realistic user engagement metric using something like Google Analytics.
Yeah, I mean, it could be cool, right? Like, or conversions or whatever. But yeah, that's pretty neat. I like that.
Yeah, to plug it to actually something that's live. Google
Yeah.
Analytics.
It should be easy because, as I mentioned, Google, any database that can be RESTfully accessed, not database, but metrics endpoint, I should say, that can be RESTfully accessed, can be used as part of these experiments. And definitely Google Analytics is one of them. So we can look up some examples that showcase that feature also.
Okay, so I think I don't see any other question, but feel free to ask. So thank you so much, Srinivasan. It was great. I guess this was a great conversation. So we are so happy that we had you here today. Please, if anyone wants to present, feel free to send me an email. And Srinivasan, you're always welcome to present, you know that. So thank you so much for being here. And I hope we can have another meetups anytime soon.
Thank you very much, everybody.
Okay, bye-bye.
Thank you.